So my name is Roderick Saylor. I work with GRW Engineers. I think I'm here to kind of discuss at what point do you want to bring an engineer into onto one of your tracks and look at rehab project or a rebuild. So I don't think I've ever been able to do one of these speeches, done a couple of them now, without kind of explaining where I came from and why I'm even here in the first place. I'm here, been with GRW for 20 years. In those 20 years, I got 19 years working with my mentor and predecessor, Harvey Helm. And one of his first clients, or GRW's first clients, was Keeneland. I think our project numbers are in the 6,000 range now. Keeneland was 100 something. So he had been working on tracks for his entire career, and I came along about 20 years ago and immediately kind of got to jump right into it. So we're a full service firm. I've worked on tracks from brand new facilities or things like Belmont, where we're kind of wiping the slate clean and rebuilding everything from scratch, down to rehab, which is I'm going to highlight one of the rehab projects that I got to work on the last year that I think was pretty neat, that I think gives you an idea of where we can be of assistance. In addition, our architectural services have designed some barns. We've done some rehab facilities, and then, for new facilities, access roads, utilities, things like that, kind of general engineering services. So when would you give us a call? So new or rehab projects is what I've referred to. New projects, pretty obvious. Rehab, are you rehabbing your base? Are you resetting your rail? What is the purpose of the project? And so the rehabs are, like I said, resetting the base. New tracks are your blank slate. You kind of get to do it, hopefully, do it right the first time, and kind of and think through the whole process, plan it out, and have it all laid out correctly. Before I really even come on to the site, we need someone like Dean, a surveyor, to come out and survey the site. GRW provides aerial LiDAR services. That's good for design purposes. It's not necessarily good to start checking grades on your track, but we do provide that. But for checking grades is where Dean or a surveyor comes in. But we can't start our work without having a good survey of your facility, of your tracks. In addition to that is either geotechnical borings and or GPR. I think we covered GPR enough a moment ago. I'll go over a little bit. Most of what I'm going to highlight was done by with geotechnical borings on the track that I'll highlight here in just a few minutes. To help us kind of all speak the same language, one of the things that I've ran into the most is nomenclature differences. What do we call things? So we're talking about crossfall or cross slope of a track, and how is that measured? In the engineering world, surveying world, planning world, it's tenths of a foot or percent. I hear it described as degrees a whole lot. What's the percent of what's the cross slope of your track? 2 degrees. Well, 2 degrees, if you look at the top chart here, 2 degrees versus 2% is a difference of 0.75 feet. So that means from your inside rail to your outside rail, you're actually higher if you have a 2 degree track. So it's a nomenclature thing, just to kind of for educational purposes. And then, as you go through, if you have a 4% track, then time you get to your outside rail, you could have, 50 feet out, you're a foot and a half higher. One of the things that we incorporate into when we can, sometimes when we come out, we're doing a rail alignment project, or it's a rehab project that includes resetting the rail or placing new rail. If in those circumstances, the track is a simple curve. So you run on your straights, and your turn is a simple curve with one single radius. That's generally some of the older tracks that we've come on to work on. What we try to include in that, if possible, for rehab projects, but definitely new projects, is providing a spiral curve at the beginning of the turn. And what that does is, there's a couple items to hit on here. First is, I don't know who's got a pointer. The TS, SC, CS, and ST, that's a tangent to spiral to curve. When you're at the curve, that's your radius that you would normally call your simple radius of your track. CS is curve to spiral. Now you're leaving your regular radius into a spiral curve back into a tangent. And what does that mean for a track? Well, here the TS, the tangent to spiral, starts really 100 feet before a simple radius would normally start. So a simple radius, a simple curve would start at the PC, the point of curvature, which is out this way. You're running a little bit longer and you start the turn later. The spiral curve actually pulls the rail in a little bit and softens that turn. It almost feels like a corner sometimes when I'm laying it out in AutoCAD or on paper. A simple curve feels like a sharper turn than what a spiral. The spiral helps you kind of ease into that turn. So this is something we try to incorporate into new tracks or rehabs when we can. Who's built a track just on their free time? This is a track that I built just playing around with AutoCAD one day, wanting to understand what would a perfect mile look like. And what it comes down to is you have a 420-foot radius, and the track here is equal lengths in all parts. So the turns, the straights are equal lengths. And in here, you'll see the items that we referred to a minute ago. You see the ST, spiral to tangent. This depends on which direction you're going. So you've got your spiral turn that goes for a period of time until you hit the CS, which is the curve, the spiral. And then the rest of this is a simple radius, the 420-foot radius going around the turn. When we're setting grades on the track, we are usually, when we come to a facility, the track super knows what he wants his cross slope to be, if it's a new construction, or what their cross slopes used to be and what they're trying to get back to. So what we will do, we'll start setting that and we'll measure, and I've got some cross section in a minute, we'll highlight some of that. But we go from 2% in the straight, and then what we incorporate the transition to be is through the spiral portion of the curve. So that first 200 feet while you're in the spiral will be the transition from 2%, in this particular case was a 6% cross slope in the track. And then you're in 6% full cross slope, full super elevation all the way around until you hit the spiral curve coming out of the turn, and it eases you back down to the 2% that's in the straight. The transition zone isn't always going to be 200 feet. It's going to really matter. This one climbed pretty good from 2% to 4, or 2 to 6. That's 4 additional percent change. So really, that one needed to be stretched out a little bit. We've done synthetic tracks that go from 0% to 4. That's 4% again change. So that transition zone getting you from your cross slope and your straight to your turn needs to be a little bit longer. Otherwise, your outside lanes or your outside part of the track is really kind of climbing uphill in those situations. And then in all the scenarios, in a perfect world, your running line is flat all the way around the track. We do our best to keep that same situation. So the running line here doesn't see the effect of it going up and down. If the track is completely flat, you're on that. You're not climbing in elevation as you go around the turn. Okay, so this was an interesting project I got to work on this year, or in the last year or two. This color map is not the same as the one with the GPR, but it is developed based on borings and depth of base material. These track owners went through the extra effort of getting borings done every 50 feet in a cross section across the track. So from the inside rail to the out, maybe 4 to 5 borings, and every 50 feet along the rail, all the way around the track. So what that did was give us an opportunity here. Let me zoom in on that a little bit. We got an opportunity to see, they pulled the cushion off, did the borings. We surveyed the top of base. And then the borings gave us an opportunity to know what the depth of that existing base material was. And so you can see in many places, it was fair. This is an example of an area that was a thin on the base. Oops, wrong way. So the other objective to this was not just understanding their base, it was also giving a consistent cross slope on the straights and the turns. So when you apply a consistent cross slope, you end up with some other variations, and I'll highlight that maybe in the next slide. But what this gave us an opportunity to do is what they really needed to do here is they knew they had this base material, that's stuff they could save, pull that off, set it aside. but underneath there, they had to get to a new base layer. The black line on the bottom was the bottom of new base. That was really the part of excavation that needs to occur in that track. So they're going to pull that off, and that's kind of spoils material to take and set it aside or contract or truck it off. But they removed the base between the two red lines. So now the difference of what they needed wasn't a full new 6-8 inches of base, whatever it needed to be. It was really just you were able to target and pull out what was usable base and what needed to be replaced. So it was a way to really tighten up the budget and assist in that without it really kind of being a super expensive project. Prior slide showed the difference of when they were measuring cross slopes, how it changed from 2%, 5 feet out to 10 feet out, and maybe 1.9 to up to 3. The bottom red line is existing track. And this kind of highlights what you would see there. And I'd almost expect on the bottom left here, you would see ponding water right at the running line. Kind of right there where it says EG 2802, that's the elevation there. Just simply because it's bottomed out and it kind of starts climbing up grade as it kind of comes to the inside rail. So here is an example of a track that needed kind of to reset the entire base and cushion and reestablish the cross slopes. So, and that's, you can kind of see that occur in both places. You can see the bottom red line on the left tried to have a crown. Maybe in the original track when it was built 30 years ago, it had a crown. But in this particular case, years of maintenance, maybe the crown wasn't in a consistent place and the maintenance folks had a hard time kind of keeping it in location. It kind of wore itself down over the years. Another similar situation, resetting the track, surfaces, and then just a couple more examples. These two here, are the same. The bottom is a little bit more blown up. The black dash line was their bottom of base, the bottom existing base. The red dash line was the top of their existing base. So as you can see, some places the base was very, very, very thin. Other locations, they had way more base than that they needed. The ultimate result in this particular cross section was taken in the beginning of a transition of a turn, 3.38%. But we averaged that out and tried to tie in our grade in a rehab situation. We don't want to reset the rail if we don't have to. Try to tie the grade in on the inside and try to really come close to tying in on the outside. And usually in that case, the board's going to make up the difference if I've got a cut situation. In addition to worrying about your consistent cross slopes, we look at what the consistency of the running line is. So these are profiles. If the horse or person is walking, running along the running line around the entire track, what does the track do? So in this particular situation, the existing base is the dashed line, and you can see how it kind of meandered up and down. So as you're going, not only do you're worrying about cross slope, being consistent, the running line also needs to be consistent so that you're not up and down as you're going along the track. This bottom example here too had a little bit of a peak in the track. So this one we took a little bit more effort to put more earthwork into it to remove a big piece of that and flatten that out over a period of time. So these are just kind of examples of where we've come in and rehab projects from an engineering perspective. We worry about the alignment. We worry about the cross slopes being consistent both in the straights and the turns. Looking at the depth of base, is the base consistent all the way around? And stormwater drainage, and make sure all the water gets out and away from the track.